Tree is one of the non-linear data structure. So we are dividing the data structure into two parts. One is a linear and non-linear. So in a linear data structure, we saw about the stack, queue, linked list, and in a non-linear data structure, you will see about the tree and the graph. So if you take the tree, it is a data structure that shows the element in a hierarchical order. Okay, it shows the element in a hierarchical order. So here the top of the tree is the root. So this is the root node, and except this root node, okay, except this root node, all the node has a parent. So for example, if a root node is A, and if you take the B, A is a parent. So for B, A is a parent. If you take C, so for C, A is a parent. Then for D, B is a parent, and for E and F, C is a parent. Okay, so a node in a general tree, it may have 0 or more subtrees. Okay, a node in a general tree may have 0 or more subtrees. And in a general tree which have a 3 subtree. Okay, if it has a 3 subtree means it is called as ternary tree. Okay, it is called as ternary tree. And in this diagram, if you see, so this is a tree. So root A it contains the 2 subtrees, and B has the 1 subtree, and C has a 2 subtree. And here it is not a tree. Okay, so it is not a tree, it is like a graph. Okay, so a number of subtree for any node may be vary. So based on that, the number of subtree will vary. So here general tree can be represented as the ADT. Okay, so general tree is represented as the ADT. There is always a problem when another subtree is added to the node. So that already has a maximum number of subtrees attached it. And even algorithm for the searching, traversing, adding and deleting the nodes become much more complex, as there are not just two possibility for any node, but it has a multiple possibilities. So to overcome the complexity of the general tree, it may be represented as a graph data structure, thereby losing many of the advantages of the tree process. So the better option to convert the general tree into the binary tree. So we can convert the general tree into the binary tree. Then next we are going to see about the tree terminologies. So consider this is a tree, and first terminology we are going to see here is a root. Okay, so the root node here, a root node or is the topmost node of the tree. Okay, the topmost. So in this example, what is the topmost node? So this is the topmost node. So this is the root node. So if r is equal to null, if r is equal to null, so what is the meaning? The particular tree is empty. If r is equal to null, the tree is empty. So here we are representing this r as the root, and if r is equal to null, the particular tree is empty. The next one is the edge. The node connected using the link. The nodes connected using the link is called as the edge. So here you can see the node A and B are connected by using this edge. So line link, right? This is called as the edge. The node connected by using the link is called as the edge. So always if there is a n node, okay. So if there is a n node, it contains n minus 1 edges. If it has a n node, it contains n minus 1 edges. So for example, if we see here, there is 6 nodes. And how many edges are there? 1, 2, 3, 4 and 5. Totally 5 edges. So for 6 nodes, it contains 5 edges. Then next one is a parent node. So node that has a children or have branches connecting to the other node is called as the parent node. Okay. So the node that has a children node or have a branches connected to the other node is called as the parent node. So the parent node have one or more children. So if you take this A, so it has two children B and C. And if you take this B, it has a children D and E. So what is the parent for D and E? B is a parent. And what is the parent for the F? D is a parent. What is the parent for E? Uh, B is a parent. So if you take the parent, it may have one or more child nodes. The next one is a child. The node that is descendant of any node is child. Okay, the node that is descendant, okay, the node that is descendant of any node is child node. So all the node except the root node is a child node. So here this is the root node. Okay, so this is the node except this root node. So B and C are child for A, then D and E are child for B, F is child for D. So except this root node, all other nodes are child node. The next one, sibling. So next one, sibling. So nodes with the same parent or a sibling. So if we take B and C, for B and C, who is the parent? A is a parent. Okay, for B and C, A is a parent. So B and C are sibling. So can we consider C and D are sibling? No, because for both the parent is different. And if we take D and D, so who is the parent for D and D? B is a parent. So D and D is a sibling. Okay. The next one, degree. So the degree of the node is equal to the number of children that a node has. Okay. The degree means degree of the node is equal to the number of children that the node has. So the degree of the leaf node is always 0. So degree of the leaf node is always 0 because it doesn't have any children. So it is 0. So if we take the degree A, if we take the node A, so what is the degree of A? So degree of A, it is 2. Degree of A is 2. And next if you take degree of B. So what is the degree of B? It has 3 children. So degree of B is 3. Then if you take C, it doesn't have any children. So degree is 0. And if you take D, it doesn't have any child. So 0. E doesn't have any child. So it is 0. Then if you take F, it doesn't have any degree. So it is 0. So what is the degree of entire tree? So what's the maximum value? It is 3. So the degree of entire tree is 3 here. And we are categorizing this into two types. One is in degree. Okay, we are categorizing into two types. One is in degree. Okay, and another one is out degree. Okay, in degree and out degree. In degree, so in degree of the node is the number of edges arriving at the node. Okay, number of edges arriving at the node, that is called as the in degree. And out degree means the number of edges leaving the node. Okay, number of edges leaving the node is called as the out degree. So it will be represented by using the arrow mark. It is represented by using the arrow mark. The next one is a leaf node, a node which doesn't have any children. That is called as a leaf node or a terminal node. So if you see here, D, E, F and C, it doesn't have any children. So it is called as leaf node or a terminal node. The next one, level number. So every node in the tree is assigned a level number, okay, in such a way that the root node is at the level 0 and child of the root node are at the level 1 and so on. So here what is the root node? A is the root node. So it is level 0. Then next, the child of the A. So it is level 1. Then child of that particular node, level 2 and level 3. So every node is at one level higher than its parent. Okay, and all the child nodes have level number given by the parent level plus 1. So A level is 0. So what is the level of the child? Plus 1. It is level 1. And what is the level for the child of B and C? It is level 2. The next we are going to see about the height. So the number of edges in the longest path from the node to any leaf, that is the height. Okay. So the number of edges in the longest path from the node to any leaf is the height. So for all the leaf nodes, the height is 0. Okay. All the leaf nodes, the height is 0. So for example, if you consider the node A, so that is the root node. So what is the height? So how much leaves are there? How much nodes are there? How much level of node? 1, 2 and 3. So the height is 3. And if you take the B, so how much level? It is 2 levels are after that. So it is 2. Then for C, it doesn't have any child, so it is 0. And if you take D, so it is contains 1, so it is 1 is the height for the D. Then for if you take E, F and G, it doesn't have any child, so 0. And what is the height of the tree? So height of the tree is the height of the root node. So what is the height of the root node? 3. So the height of the tree is the 3. The next one, depth. The number of edges from root node to the particular node is the depth. The number of edges from root node to particular node is the depth. So here the depth for the root node is 0. So it is reverse for the height. The depth of the root node is 0 here. Okay. And depth of the tree is depend upon the longest path from the root node to the leaf. Okay, longest path from the root node to the leaf. So if we consider the depth for A, so for root node it is 0. And if we take B and C, so from B and C there is only one node, that is root node, so it is 1. And if we consider D, E and F, so before this there is two level of nodes, so it is 2. And if you take the G, it is 3. So what is the depth of the tree? So depth of the tree is longest path from the root. So what is the longest path from the root? It is 3. So depth is 3 here. The next one is a subtree. So if the root node R is not null, okay, if the root node R is not null, then the tree T1, T2 and T3 are the subtree for the root. Okay, so if R is not null, so if R is equal to R is not equal to null, the T1, T2, T3 are the subtree of the R. The next, forest. So the forest is the disjoint union of the tree. Okay, forest is the disjoint union of the tree. So the set of disjoint tree or a forest is obtained by deleting the and the edges, counting the root node, 2 nodes at the level. Okay, so the forest can also be defined as an order set of 0 or more general trees. So while a general tree must have a root, the forest on the other hand may be empty. So because the definition, it is a set and the set can be empty. So here what is the forest? B, BC, and these are the forests here. Then path. So the sequence of consecutive edges is called path. Okay, sequence of consecutive edges called as the path. So the path from node a power 1 to a power k, it can be defined as the sequence of a1 comma a2 comma a3 up to a power k. So here a power I is the parent of a power I plus 1. Okay, so here for 1 is less than or equal to I, less than or equal to k here. So if we take this example, what is the path from A to G? So we can travel from A to B, then B to D and D to G. So this is the path. And what is the path for F? A to B and B to F. It is a path. The next one, length of the path. So the number of edges in the path. So for example, if you are taking A to G, so what will be the length? So what is the path here? So the path is A to B, then B to D, D to G. So how many after A, how many edges are there? From A to G, how many edges are there? There is 3 edges. So the length of the path is 3. Okay, the length of the path is 3. The next one, ancestors. An ancestor of the node is any preceding node on the path from root to that particular node. Okay, an ancestor of a node is any preceding node on the path from root to that particular node. So the root node doesn't have any ancestors. For example, if you take the node A, C and G, okay, so are the ancestors for the K. So what are the ancestors for the J, A, C, G? what are the ancestor for the F, B and A? So the ancestor of the node is any predecessor node on the path from root to that particular node. And descendant, a descendant node is any successor node on any path from the node to the left node. So here leaf node doesn't have any descendant. So for example, if we consider A, so what is the descendant for A? It is J, G, C, A, or we can take K, G, C, A. So these are the descendant for the node. So these are about the terminologies of the tree.